That should work. All right, cool. So, hi everybody. Thank you for coming this evening. Thank you, John and Ryan and all the other organizers for the invitation. I'm excited to be here, and I was especially happy to collect my OCRUG mug, which I will sip from occasionally to calm myself down. Yeah, it's great to be here. I'm excited to speak to you on this topic because it's something that I personally put a lot of effort into, working on, thinking about, and playing with. And I always relish these opportunities to come out and talk with people about this stuff, but particularly in a setting like this, where I can easily collect questions from anyone who's interested in working on this. And I plan on staying for some amount of time afterward if you have any questions. Considering the size of the room, I would say feel free to interrupt me with questions if you feel particularly lost or have a great point to make. That's totally fine. So thanks in advance for making it a little more interactive. And there will be points where I'll be soliciting feedback, so if you help me out there, that'd be great. So, like John said, my name's Alan Diapert. I work at our studio on primarily Shiny, but if you know anything about Shiny, you know Shiny means a lot of things. There's Shiny the package, but there's also Shiny server, and there's all kinds of stuff related to Shiny. Collectively, I consider all those things the Shiny ecosystem. So I'm not going to be speaking about Shiny itself, the Shiny package, but I am going to be talking about how the Shiny ecosystem connects with other technical ecosystems. Now, I think maybe the greatest thing about Shiny is the way that it bridges the R ecosystem and our ability to write software and do analysis in R with the world of software delivery, which is the ability to give the ability for people to look at your stuff in a web browser and not need to know what R is. So let's dig in. My goal with this is to give you enough information to come away from the talk not just knowing what JavaScript is, but understanding how it relates to what Shiny does. Have a basic understanding of how Shiny works with respect to JavaScript, and then also have an understanding of what this React.js thing is and how it fits into the equation. And then finally, we'll kind of pull it all together by introducing the reactR package, which is an R package and an R resource directed primarily at R users that is an effort to make a lot of this easier for the R user, the R developer, the statistician, the analyst to bring to their own projects, their own work. The menu for the evening. We're going to talk a little bit about how Shiny works at a very high level and introduce this concept of unidirectional data flow, which is a very fancy word and which will get you in any computer science conference you choose to go to. We're going to talk about what happens in the web browser when you visit a Shiny application. Again, this is giving us context and giving us vocabulary to talk about React. Then we'll finally introduce React.js. Try and convey what it is, what it's for, why it's cool, what it has that we're interested in leveraging. And then we'll talk about reactR, which is this R package that bridges these two ecosystems, the Shiny ecosystem, the JavaScript React ecosystem, and hopefully makes it easier for people in this room and people in the R community to leverage the power of React. And then, time allowing, we'll do some live coding with many asterisks around what exactly we'll achieve during that, but hopefully I can use some of that time to dig in particular topics people have questions about and to point out some more esoteric technical things that I might not have slides for. So, how does Shiny work? Well, this is a very, very high level architectural diagram, but basically there's a user, a person, who clicks on things on the web page and they see things happen in response. And the web page here is inside a browser window, and that's a program running on your laptop or your desktop or your phone. And then finally, that web browser is sending and receiving data to and from some server. Now, in a lot of cases, if you're using Shiny on your own machine, like on your own laptop, the server is your laptop. In fact, most people who use Shiny for apps that are just for themselves or if they're just making a particular R Markdown report with the Shiny stuff in it, for example, that may just be running on their machine. But the server can be remote, which is what the RStudio application hosting stuff does, like Connect and Shiny Server Pro, so that you can move things from your desktop, your laptop, into the cloud. So, most important thing about this is that there's a concept of unidirectionality here. So these entities form, in computer science, we call this a directed acyclic graph. But basically, it's a line starting with the user. The user enters data into the app. Here it's clicks, but it might be typing text in a text box or moving a slider. It's generating events. The browser is intercepting those events, and it's converting them into network traffic. Network, pieces of information go over the network, and they're received by the server. The server, in this case, is running an R process. The R process has the Shiny package running inside of it. It does stuff with those events. What kind of stuff will it do? What's something a Shiny app does? Anybody hazard a guess? What can a Shiny app do? What can a Shiny app do with a number that you give it? To make sorry, in the back.
The user passes in a number and it can update the code, rerun it, and give the user an updated image or feedback.
Exactly, exactly. The server will take that information from the user and it will do something interesting with it, like maybe it was a drop-down box and you selected from one of 5 colors. You selected red. Oh, well, that's a variable we're going to plug in on the server side in your ggplot and make your facet borders red. So the user combines data from the user with some logic provided by the programmer, which in a lot of cases is the user, but could be anyone using the app. Then it will produce a new piece of data, which in the example the gentleman submitted might be a new plot, a new image, but it could be other things too, like new pieces of text or a PDF, something. That gets sent back down the network pipe into the browser. Let's say here's the new plot, and then the user sees it. And that completes this cycle, the directional data flow. For the rest of the talk, I'm just going to focus on what happens inside the browser. So the browser was that middle piece. There are other talks about what happens on the server. Tonight we're just going to talk about what happens in the browser because that's the part of this process that relates directly to JavaScript and React.js. So inside the browser you can also see a well, it's not unidirectional, but it is a data flow. There are events being produced and consumed by different pieces of things in the browser. So here we have the user again. When the user clicks a button, that creates an event object. So that it instantiates a kind of programming object in the browser. And the browser API, or the browser functionality related to this production of events, is called the document object model, or the DOM. That DOM passes these events along to the programming language JavaScript. So JavaScript is a whole other programming language, just like R. It does a lot of stuff R can do with functions and loops and all these things. It's a general purpose programming language, asterisk, because there are some caveats. But by and large, it's pretty much a full-blown programming language that lives inside your web browser. And when we're writing an application that needs to respond to events like this from the user inside the browser, we write those applications in JavaScript. So even though a lot of the Shiny package and packages related to Shiny are written in R, that R code is the stuff that's running here on the server. A significant fraction of the behavior that you would ascribe to a particular package actually happens here in the browser, and more often than not is implemented in JavaScript. So there's a lot of overlap between the capabilities of R and the capabilities of JavaScript when it comes to producing an artifact for someone to use in the R ecosystem, like an HTML widget, like Leaflet or Plotly or something like that. So this JavaScript code, it's passed these events from the user, and it can do one of two things with those events. The first thing it can do is it can directly manipulate the DOM. The DOM here is the programming object that controls what the user sees. So one thing you can do in JavaScript, for example, which is really annoying, is you can present a little thing that says this site uses cookies. Anybody seen those? Oh, there's so many things now, like this site uses cookies. Can we use your location? All of that evil comes from here. That's somebody's JavaScript code running and saying, oh, this user hasn't received our evil yet. Let's try and deliver them some new evil and waste their time. All that's happening here, and they're doing that by changing the document object model. And the document object model is what, basically it's the equivalent of like cat. So it's the way you can get things out to the user from JavaScript. So I mentioned that JavaScript doesn't just receive events from the DOM. It can, and that's a big part of what it does, but it can also receive events from the server. A lot of apps have this unidirectional data flow, but a counterexample to this architecture is a chat app. Because in a chat app, somebody else is making an event, and you didn't do anything to see it. It is sent to you from the server to your eyeball. So that's not really a unidirectional data flow because events are happening that the user, any particular user, didn't initiate. So it turns out quite a few apps follow that pattern, like any kind of app where the server is generating data, like a stock ticker, any kind of metrics coming out of IoT devices, any sensor readings, things like that. This is data coming into the app, possibly, potentially coming into JavaScript, that is not from users, but users will want to see it and may want to respond to it. Let's see. Right, so focusing in on this particular, or these two things, the DOM and JavaScript, colloquially, that's what people are talking about when they refer to the concept front-end web development. Yes, sir?
Yeah, I have a question.
Oh, yes. Sorry, multiple.
Okay.
Please go ahead.
Okay. Actually, normally, for example, we use the R. We have R package, use a Shiny package. So for my experience, I just open the write R code, use R package, and get the Shiny the program, and never touch a JavaScript.
Yes.
So is that a JavaScript controlled R package, or should I write some the Java, the code to run this one?
So in a lot of cases, you know an R package is well written when you don't need to know any JavaScript to use it, right?
Yeah.
So everything I'm talking about here is, I don't know, what we call implementation detail. So if you were to want to go and make a package like that, this is the stuff that you would want. So depending on whether or not you want to learn this stuff, take it as seriously as you want. But yeah, React, this tool we're going to introduce, is at that level of implementation. So we've done a good job as package authors when you don't have to know any of this. And nobody's walked out, so I'll keep going. Any other questions before I continue? Yes, sir?
So is that the WebSocket protocol between the JavaScript to the server?
Correct. Yes. Oh, sorry, this. Yeah, there are other protocols too, HTTP primarily. WebSocket, I don't know how much you want to know, but there's, when you go to a web app, you're downloading all kinds of stuff, images, style sheets, and WebSocket is just one of those pathways. But it is significant in Shiny because whenever you move a slider in Shiny or whenever a plot is updated, that particular data is going over this WebSocket thing. Yep. Any other questions? All right, let's roll on. Okay, so I mentioned that when you hear people talk about front-end web development, this is what they're talking about. Front-end web development is its own enormous ecosystem, pastime, career path. I mean, they have giant conferences. Big companies have, multi-thousand person team front-end web development groups. It's its own whole thing. And so it's interesting to us because this is a big part of how Shiny works. And to the extent that there's a lot of cool stuff happening in web development, it's nice from the Shiny perspective when we can kind of go over to their world and just kind of pick some nice things. Oh, I like that. You guys made a cool data grid. Let's see if we can use that, pull that into our Shiner project. Or maybe like D3 is a really cool way to visualize stuff. That's a JavaScript thing. Well, let's see. How can we sort of pilfer that and bring it into the R ecosystem? So it's good to keep an eye on what's going on in front-end web development world, because front-end web development world demonstrates the capabilities that we might someday be able to leverage from our Shiny stuff. React is one of those things. I think it came out around 2013. It was introduced. Originally, it was developed in a company, well, Instagram, I think, developed it, and then when they were bought by Facebook, Facebook started to use it internally. And so by the time it was released in 2013, it was a fairly mature JavaScript library. And there were a series of talks where it was introduced, and it changed the landscape of front-end web development. And I think today is more or less synonymous with front-end web development. I know people, our studio is hiring with this background. Generally they are, in order to call yourself fluent in front-end web development, you have to know something about React. So it's become part of the woodwork, sort of like jQuery was 10 years ago. It's still one of a few approaches. It is not the way to do front-end web development, but it's certainly one of the most popular, if not the most popular. It introduces the concept of a component. And a component in React terms is sort of like a function in R. So in R, if you have some behavior or some algorithm that you want to encapsulate, you might write a function. JavaScript has functions, but there isn't a natural way to encapsulate both the behavior of something and the way it looks. Or there's not an obvious way to do it. And React proposes this idea of a component, which is a unit of modularity that is very easy to use and people have used to create lots of really cool stuff. So when you're building an app out of React, you're building it out of these components. They build on each other the same way a program is usually built out of a lot of functions that call each other. All of this is interesting to us from the R world because people out there in the React world are constantly making cool stuff, cool libraries, cool visualizations, cool gadgets and gizmos. You can't see these very well, but this is a really cool table rendering package from the React world that actually has an R package version called reactable. There's this awesome React Components GitHub project where you can go, and not everything will be directly accessible to you from R, but it's a great place to go for ideas. And then this is just a color picker that we're actually going to take a look at here in a second. Okay, front-end web development. Shiny is basically a web technology. React is a front-end web development library. What is reactR? Well, several years ago, around the time that reactR came out, there was a gentleman in the R community named Kent Russell. And he's a JavaScript enthusiast, and he's a prolific Shiny HTML widget person. He saw React and he thought, oh, I want to play with this. And when he was playing with it, he started making tools for himself to make it easier to use. And the product of that effort was this package, reactR. So it's been on CRAN for, I think, like 3, 4, or 5 years even. And it's great. It's an effort that bridges the two worlds. I don't know, I think it does a lot of stuff. It has a lot of stuff in it that's useful if you're interested in this technology. The biggest thing is that it documents how to combine JavaScript, React, and R. So even if you don't end up using the package, the documentation may be of value to you because it explains a lot of things in the JavaScript ecosystem in terms of R things that you might already know about. So that'd be great. It provides a software, like actual interfaces, actual JavaScript code that allows you to glue together existing R stuff with JavaScript stuff. And finally, it doesn't do anything new that doesn't compose with anything that exists already. So it integrates well with Shiny and HTML widgets and our other stuff in this space. Right, Kent Russell. Like I said, prolific contributor. It's hard to see down there. His Twitter thing is Timely Portfolio. There was a time, I think 2 or 3 years ago, he made an HTML widget a week, and he ended up producing, 52 R packages in a year, which is just unheard of. That's insane, but he did it. Right. Any other questions before I go into the demo? Yes?
Is the timely portfolio guy working for RStudio now?
No, he isn't. No, we couldn't contain that. It's too much energy. No, he's very happy doing what he does. He's like a portfolio manager or something somewhere, I don't know. But he's happy doing what he does, and he gets to do, it seems like he gets to do a lot of open source, so I'm not sure there's anything we could do to motivate him more. But I'll keep asking. Okay. So, I mentioned we have all this cool documentation. Well, here's one that I'd like to point out, which is a pretty extensive tutorial about how to create your own Shiny input. So you've all used Shiny inputs, text inputs, sliders, buttons, but sometimes you want your own. You want to make a new one. And with reactR, that's not just possible, it's actually easy-ish relative to doing all of this bottom-up by yourself. We have instructions on this tutorial. Oh, I should point out, this is the reactR web page. Basically, if you type reactR into Google, go to the GitHub page, and then click on the home page, you'll get to this URL. I'll be sharing all these resources with Ryan and John, and they'll be posted, I'm sure. So, this article covers the software you need to install for building the JavaScript pieces. And it also covers our scaffolding tools for building out a widget. So let's see, I've got let's give this 5 minutes. Let's see if we can make an HTML widget from relative scratch in 5 minutes. All right. So I mentioned there are a lot of cool React packages. There are libraries, they call them in the JavaScript world. This is a cool one. Look at all the colors I can pick. So many colors. On the big screen, that's kind of a cool effect. That's a lot of pink right there. So this is a neat React library that basically lets you use like a million different color pickers in your app. I don't know why you'd want to use all these color pickers in your app, but let's not ask that question. Let's just see if we can use this in R somehow. Okay, what do we have to do? Well, we need to run a bunch of code, some R code. I'm going to drop in to RStudio. Clear this. So this is calling use this, create package, rock and roll. Oh, whoops. I have to give it a new name since I call this color picker 2. Okay, so this is a new RStudio project called Color Picker 2. Go back to this tutorial. Okay, now I need to run some code that does more scaffolding, generating configuration files for JavaScript things. Paste that in here. Okay. Go back to the tutorial. Actually, before I go back to the tutorial, go to the project. So, it's difficult to see. I don't think it says the directory I'm in anywhere. But I'm in an RStudio pane in a new project that we just generated using stuff provided by the reactR package. And this project is called Color Picker 2. And there are a bunch of files in here that it generated for us. There's a description file, namespace file. There's an R directory, probably with some stuff in it. And then there's a bunch of weird looking things like package.json, webpack config.js, and so on. All that weird stuff are JavaScript tooling configuration things that we omitted for you. All right. So now we need to build the JavaScript, and to do this we're going to use a build tool that I had previously installed. It's the premier JavaScript build tool called Yarn. Let's see if I can do this. Yarn. Color Picker 2, Yarn, run webpack. Oops. I need to do Yarn install.
While that's installing, you said that you omitted, those were omitted?
Sorry, emitted.
Emitted, okay.
Yes, yes. It's basically boilerplate stuff. Yeah. Yeah, if it were omitted, then
I'm so confused.
That'd be going backwards. Yeah. Okay. So I ran that command. I'll run the next command on the tutorial. And this is doing JavaScript compilation stuff, the details of which are not totally material, but if you're interested, they're explained in this tool, or in this document. Okay, then we got to do DevTools document and DevTools install. Okay. Okay. And now, the package that it generated contains a test app that uses the input that the package has inside of it. We'll look at this app in a second. But it's a very boring input. It's like the echo input. You just type something in the text box and it sends it back to you. But this is a good starting point because it does that round trip that we were talking about earlier. And if we look at our example app, we can see what looks like a pretty generic Shiny app. But the interesting thing about it is that it includes color picker input, which is that basic echo input that we just scaffolded. So it's there working for us, and we can look at its code and hack on it from here to turn it into the input that we want. I think I've got just enough time to bring this full circle. Let's see. Yeah, I don't think I'm going to make it easily. But if you would like to continue, you can do the steps that I just did on my machine on your machine using this article as a guide, which is the authoring inputs powered by React with reactR. And hopefully you have enough time to get to a point where you have your own color picker showing up in the example application. And certainly if you have any problems, you can reach out to me. I'm happy to help. Yes?
So there's a way to just find a pre-developed React module, the right
Library or
library.
component? Correct.
And then you have it set up so that all I need to do is put that into a wrapper, I'm assuming,
Right.
so that then I can call that within Shiny
Yes.
as a function.
In a lot of cases, not always. I can talk about that part. I think we have another minute or two. So we saw all these different kinds of pickers, and I previously mentioned this concept of a React component, which is like their unit of functionality. And you can see in their documentation, they have all the pickers broken up into a set of these components. So a big part of what reactR does is, given some R code and given some documentation for JavaScript components like this, or React components, our stuff lets you fairly easily port these in to the R world. So you still have to go look at JavaScript stuff and understand a little bit of JavaScript stuff to make headway with this. But once you get to something like this kind of documentation, then you can go back to your project and where is it? I think this is the JavaScript code that we needed to write in our package to import that sketch picker, which is the Google Sketchup looking color picker.
Does our studio have like you know how it has like a new project, new package? Does it have one for this where it will write you the Java, give you the template for JavaScript files and stuff, or how are you doing?
No, and actually, at least this version of our studio doesn't even have support for JSX, which is this kind of JavaScript. The support is not that great in the editor. So honestly, don't tell RStudio. I don't use RStudio for JavaScript. I use other things. But VS Code is a good one. But yeah. There isn't IDE support for this yet. Any other questions? Yes?
So Alex, the idea that you can write JSX code in another editor environment, and then you can, using the R language, you can wrap those functions
Yes.
and call them directly in R.
Yes.
You're running R that is calling JSX, that is interpreted to JavaScript, that is transpiled to C++.
Well, So his question was, are you running JavaScript inside R? And there aren't that many levels of inception here, because we're developing the JavaScript and the R in parallel. It's not like one is happening inside the other necessarily. They're basically two different languages. One is for the front end, one is for the back end. And we're developing them in parallel in the same development environment so that we can connect the two and deliver functionality. Does that make sense?
I think so. I'm trying to run this program in RStudio, and I'm getting some complaints by the editor that it doesn't recognize the system you want to install command quickly.
I can swing by your laptop afterward. Any other questions before I go? Yes?
I assume you, with these widgets, for example, you want to get a color out on the end. Is there some limitations on what the widgets can spit back out to the Shiny and R? Or
Basically, no.
you can map the...
We make the simple thing easy, so assuming it's some small value that you want to send over, we make that easy. Like JavaScript strings are character vectors and stuff like that. We map the types. But basically, no, there's no inherent limitation in the kind of data that you pass back and forth. Yes?
Sorry, kind of a silly question. This question about RStudio server. Is there, let's say that you needed an R script to be executed at like 9 a.m. every Friday, for example. Is that something that an RStudio server would do? Is that something our server would do at all? Is that even, or is that in a different area?
That's a different area, but that's fine. I'm happy to chat with you afterward.
Thanks.
All right. Well, I think I'm out of time. But thank you so much for coming, and thank you for the great questions. And find me after this if you have more questions. Thank you very much.